So I want to write a function for this piecewise graph. Hopefully you notice over here I have 4 functions that make this full function. Do you see I have 4 different functions here? And we're going to describe each one and talk about the interval in which they're present. So the first one I'm going to talk about is red function. That red function, hopefully you can tell that red function, let's call it a polynomial. Normally, you'd have to actually put the equation of the polynomial, but right now what I'm just going to do is say the word polynomial as the red function. And then we talk about the interval. Now the interval is from this. Can you tell this red function goes from all the way over here and just keeps going and stops right here at -1? That's called the interval. So the interval for which this red graph is we call it x is values less than -1. So the polynomial function, that red piece, is for all values x of less than -1. Okay, let's go to the next graph. The next graph is this blue one right here. Hopefully you can see for that blue graph, do you see how it stops right there to there? See what's in that little window? Okay, can you tell that blue graph is a line? So I'm going to call it linear. All right, just to describe it. In the future, you have to actually give the equation for that line. But that's a linear graph. And are we okay? Is that increasing? Is it decreasing? Is it flat? Well, can you tell it's increasing? So I'm just going to describe it as increasing. Just as a little bit better description. Just so I know, oh, that's a linear graph that's increasing. Because there's other things going on. And the interval for which that is, well, isn't that between -1? Isn't x between -1 and 1? Are you okay with that? Isn't x between -1 and 1? Isn't that the area, the space it's in? Now, you might wonder, why are these less than signs there? That's how you write it. I'll describe it sometime in the future or something. But for now, they're just less than signs. It's saying x is between -1 and 1. And I'm going to add something else. Don't worry too much about it, but I'm going to put an or equal to here. The reason is since that's -1 and that's -1, one of these two graphs has to claim -1. That's not a big idea right now. Right now, just realize -1. This one's less than -1. This is from -1 to 1, and I did claim this. There's a reason, not a big part of what we're trying to get at right now. So don't let it be something that distracts you. Next one. Let's do this green one right here. That green part of the graph right there. Well, can you tell it's from here to here? Can you tell it's linear again? Can you tell it's flat? So we're looking at the green one as a flat linear function. And can you tell it's from -1, the x is between -1, oh, not -1. Let's take that back. It's not -1, it's between what? It's between +1 and 2. Is that correct? And we put less than signs. And I'm going to put a line underneath this for a reason. Because since I did not put a line underneath this one, I got to put a line underneath this one. There's a reason. The key idea is, do you understand it's from 1 to 2? The blue one's from -1 to 1. That's the most important. X is between those. And the last function. Well, can you see this last function is this purple one right here? What kind of function is that? Well, can you tell that purple is another linear? And is that linear decreasing or increasing? Well, hopefully you can tell it's decreasing. So I'm going to give it a little bit better description. And on what interval is that purple line? Well, isn't it from here on forever? So how do we describe that? Well, isn't it x values bigger than 2? And since I didn't claim 2 here, don't I have to put a line underneath here? Because I did not claim it for that one, it's going to be values greater than or equal to 2. So this right here is a piecewise function description of this graph. In the future, you will actually have to find the equations of each equation. This line, this line, this line, and that polynomial, and find each individual equation. It's a little bit harder. But for now, we're just kind of, hey, what are they describing? And we're describing the interval. Now, I'm going to give you a new notation for each of these intervals. There's another way to describe them that you also will see. This is what's most common for piecewise. But this next notation, I want you to write down and really understand this next notation is just another way of saying the same thing. This one right here is saying negative infinity to negative 1. Are you okay that less than negative 1 is from negative infinity to negative 1? Hopefully that's okay. The next one, can you understand it's from negative 1 to 1? The thing is, can you make this side a bracket? Are you okay? The next one is from negative 1 to 1. Now, I made this one a bracket because I have an or equal to. Think of it as grabbing it, where the 1 is just the edge of it. Let's try it again. This next notation is going to be from bracket 1 to 2. Do you see why I bracketed 1 again? Because it has the or equal to. And then the last one, isn't it going to be from bracket 2 to infinity? Again, the brackets are just because I have or equal to's. And all you're doing is writing the same kind of interval here, but you're putting it in parentheses and brackets. And if you're on the edge, don't you always go to infinity or negative infinity? This is actually the more common notation for the problems we're going to be doing. This right here is more common for piecewise, but both are called interval notations. They describe the window each graph is inside. And the colors help. You kind of see, okay, this graph is in this interval, and this is where we're leading with this in piecewise. Now, real quick, from this piecewise, just a quick little extra. Can you tell where the functions have maxes and mins and stuff like that? There's going to be a whole bunch of questions we're going to ask